This is part 2 of graphing bar graphs and histograms. So we already did 1 through 4 in the previous video. Today we're going to do number 5. So reading number 5, it says the Center for Disease Control gives statistics relating to the leading cause of death by age group. The number given is the percentage of total deaths. The data gives the 6 leading causes of death for 2 age groups, 10 through 14 and 15 through 19. Consider this as 2 sets of data. The first is the leading cause of death, ages 10 through 14. So that would be this data table here. And the second as the leading cause of death for ages 15 through 19. So this would be that data table here. A says explain why each of these 2 sets of data is categorical. Name the categories for the data. So we know that categorical data means that you're separating them into categories. So here are the different categories of leading causes of death. So that's going to be our answer for number 1. The data is separated into different categories. So the different categories are going to be unintentional injuries, cancer, homicide, suicide, congenital defects, and heart disease. Those are our different categories. That is what goes down here on the x-axis of your bar graph. So we need to put a title down here though. So the title is going to be Types or Causes of Deaths. So that's going to be the title for our x-axis. Then it says the graph is a double bar graph. So that means you have 2 bars that are going to be side by side. So yesterday, or in part 1, we discussed how bar graphs are not next to each other. The bars are not next to each other. But if you're comparing the same thing, like the ages of 10 to 14 and 15 to 19 for the same category, then your bars will touch. But you can see that the different categories are not touching. So it says complete the graph using the information in the data table. Use either pattern as shown in the partial bar graph or 2 different colored pencils to differentiate between the age categories 10 to 14 and 15 to 19. Label the vertical axis and create a title for the graph. All right, so it has already given us a scale, which is 0 to 50. We could have determined that. We know because we started at 0 and we know that our highest percentage death is close to 50%. So we're going to go up by 5s. So it would be 0, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. And we discussed yesterday, or in part 1, the best way to create a scale. So our title for this y-axis is going to be frequency. Because we're talking about percentages, or the percentage of death in those specific ages. So I'm actually going to use 2 different colors. I'm going to use yellow and pink for our different age groups. So I'm going to color in the 10 to 14, which is going to be yellow. So our yellow is 10 to 14, and then our 15 to 19 is going to be pink. All right, so when we draw these graphs, we're going to start at cancer next. So we're going to look up here at cancer for the 10 to 14, and we see that it's 12.2%. So looking at how unintentional injuries work, they're going to be straddling this line. So my 10 to 14 is going to be left of that line, and my 15 to 19 is going to be right of that line, but they are going to be touching. So if I'm at 12.2%, I'm going to go up to 10. I'm slightly above 10, but not to 15 just yet. And I'm going to draw my bar there. And we mentioned in the previous video that you need to have straight lines and the bottom of your graph needs to be sitting on the x-axis. And because it's the 10 to 14, I'm going to color it yellow. Now, Cancer in the 15 to 19 is at 5.4%. So I know that my 5 is right here, so I'm going to go slightly above it. You can't really even tell because that is such a large span. And I'm going to color it pink because that's our 15 to 19. On the next one is Homicide. So I'm going to go to my 10 to 14. I'm at 6%. So I'm just slightly above that 5% line. And I'm going to make my graph or my bar. I'm going to color it yellow. Then for my Homicide of 15 to 19, I'm at 15.2%. So I'm going to go up to 15. You can't really tell that it's going to be above it because it is just 0.2, which is a very small percentage. So it's going to be basically sitting on that 15 line. For Suicide, I'm at 5.9%, so I'm going to be very close to the 6% line, which is just slightly above 5. Now, as you can see, all of my bars are about the same size. We don't want to do separate sized bars. We want them to be pretty consistent. Suicide for 15 to 19 is 11.7, so I'm going to go up to 10, and I'm just slightly over the 10 mark. And we remember to color it pink. For Congenital Defects, I'm at 5.4%, so I'm right at that 5% line, and I'm coloring it yellow. And then 15 to 19 for Congenital, I'm at 1.6, so I'm very small down here. You can barely see it. Then at Heart Disease, which is going to be our last one, I'm at 3.9, so it's very small. But it's very close to the 5% line. And I'm going to color it yellow. Then for 15 through 19, I'm at 3.4. So it's very close to what I was for my 10 to 14. All right. C says, is the bar graph or the table a better way to analyze the data? So really, it just depends. The bar graph is better because it is a visual representation. But because you can see, if you're wanting precise numbers, then the data table would be better. So it just depends on what you're wanting. If you're wanting a visual representation, then the bar graph is better. But if you're wanting it to be precise, then the table is better. So it just depends on what you're wanting it to be. All right, flipping it over to the back. Looking at D, it says, what do the numbers on the vertical scale represent? So our vertical scale was right here. So that's going to be the total percentage of deaths in youth. So we could have also labeled that as our title. So we could have said, percentage of death in youths as our title as well. Now, there is one thing that we did not do. We did not put a title right here. So we need to put a title that sums up what this data table is. So we're going to say leading causes of deaths in youths. So that is my title, and I have my key down here. And that's very important to remember, is that you have a key when you are comparing two separate things. All right, so flipping back over to the back. So the numbers on the vertical scale represent the percentage of deaths in youth. E says the model for each group is unintentional injuries. Would the mean and the median of each data set provide meaningful information for this data? Why or why not? So no. The mean and the median of the categorical variable causes of death cannot be calculated. So no. On F, it says, based off the graph, which cause of death is the difference between the two age groups the least? Consider the situation and explain why this difference might be so small. All right, so the smallest difference is between the groups is approximately 0.5, which occurs in heart conditions or heart disease. So you can see right here on your data table or in your graph, you can see that the bars for all of these are pretty significantly different except for heart disease. Heart disease, you can see that it's just a very small percentage. And that's going to be because most of the time, the heart disease, it's not closely related to young people. Most of the time we see older people have heart disease, so that's why it's going to be at such a small percentage, and that's why it's not really different in the two different groups. So heart disease at 0.5%. So it's mostly older people that we're going to associate heart disease with, not younger people. I will come back and do a part 3, which will answer number 6.